बड़ी गर्मी लग रही है, पंखा चलाएंगे?
बात होती है।
पंखा
किधर अभी कैसे चला रहे थे?
मैं ये सोच रहा हूँ इसको बंद किया हुआ है, ये घूम ही रहा है ना तो good morning, learners and viewers. Welcome to the session of Operations Management MMPO 003. Today, I will be continuing with Unit 4, that was Process and Capacity Analysis. To understand the different type of manufacturing processes, they are basically classified into four types. That is job manufacturing process, batch manufacturing process, mass or flow manufacturing process, and process type manufacturing process. Basically, how this classification is done. It is basically a relation between product variety and production or operations volume. Or rather, we can say that different types versus volume. If we talk about job shop production, here varieties of product produced is small. That means variety is very low. We, we have to work on a specific product. It, its basic example can be painting shops, machine tool shops, because they are performing a single job. Then comes your batch production. That is, the products are produced in lots, groups, or batches. Or here, the variety is medium, volume is medium, and medium quantity is also medium. The best example what we can take is drugs, manufacturing of drugs and pharmaceutical companies, chemicals, or we can say manufacturing of breads, biscuits. The third one is mass flow inline production, where variety is very low and volume is high. That means it's a continuous one. The best examples for them is automobile plants, food processes, beer bottling. The fourth one is process type manufacturing process, which is continuous flow production. That means it will be continuing for 24 into 7 production all over the year. Volume is very high and variety is very low. Examples: petrochemical refineries, edible oil refineries, steel making, paper making, beer brewing. Now the question is, what are the factors which affect the choice of manufacturing process? That is the effect of volume and variety, capacity of the plant, lead time, flexibility and efficiency. Then comes your capacity planning. Capacity planning is to be carried out keeping in mind future growth and the expansion plans, market trends, sales forecasting, etc. It is a simple task to plan the capacity in case of stable demand. But in practice, the demand will be seldom stable. It is fluctuating. The fluctuation of demand creates problem regarding the procurement of resources to meet the customer demand. Production managers are not concerned about the capacity of the following reasons. Sufficient capacity is required to meet the customer's demand in time. Capacity affects the cost efficiency of operations. Capacity affects the scheduling system. Capacity creation requires an investment. And capacity planning is the first step when an organization decides to produce more or a new product. Managing a process to meet demand. Ideally, the capacity of a process will be such that its output just matches the demand. Excess capacity is wasteful and costly. Too little capacity means dissatisfied customers and loss of revenue. Having the right capacity requires having accurate forecasts of demand, the ability to translate forecasts into capacity requirement, and a process in place capable of meeting expected demand. What is process variation? Variation occurs in all business processes. It can be due to the variety or variability. If we take up an example of random variability is inherent in every process. It is always present. In addition, variation can occur as a result of deliberate management choices to offer customers a variety. Variation can be disruptive to operations and supply chain processes, interfering with optimal functioning. Variations results in additional cost, delays and shortages, poor quality, and inefficient work systems. Poor quality and product shortages or service delay can lead to dissatisfied customers and can damage an organization's reputation and image. Capacity decisions are strategic. For a number of reasons, capacity decisions are among the most fundamental of all the design decisions that managers must make. In fact, capacity decisions can be critical for an organization. Now, how they can be? Capacity decisions have a real impact on the ability of the organization to meet future demands for products and services. Capacity decisions affect operating cost. Ideally, capacity and demand requirements will be matched when we are working. When the planning is done, capacity is usually a major determinant of initial cost. Capacity decisions often involve long-term commitment of resources. Capacity decisions can affect competitiveness, and capacity affects the ease of management. That means managing things. Now, defining and measuring capacity. Design capacity, the maximum output rate or service capacity, and operations process or facility is designed for. And your effective capacity is the design capacity minus allowances, such as personal time and maintenance. Design capacity is the maximum rate of output achieved under ideal conditions. These different measures of capacity are useful in defining two measures of system effectiveness, that is, the efficiency and utilization. If we talk about efficiency, efficiency is basically the ratio of actual output to effective capacity, whereas your capacity utilization is the ratio of actual output to design capacity. Now, mathematically, it is efficiency is a ratio of actual output to effective capacity multiplied by 100. That means it will be in percentage. And utilization is actual output upon design capacity. Both measures are expressed in percentage. It is not unusual for managers to focus exclusively efficiency, but in many instances, this emphasis can be misleading. This happens when effective capacity is low compared to design capacity. Developing capacity strategies. There are a number of ways to enhance the development of capacity strategies. Different processes, what we do. Some of them are explained over here. That is the design flexibility into the system. Take stage of life cycle into account. Take a big picture of that is systems. Approach to capacity changes. Prepare to deal with capacity chunks. Attempt to smooth out capacity requirements. Identify the optimum operating level and to choose a strategy if expansion is involved. The system viewpoint includes good ideas which can increase supply chain capacity with minimum expenditures. The formula for actual measured capacity of a manufacturing or service department is given by this relation. That is, C capacity is equal to T multiplied by E multiplied by U, where T is the real time available, E is the efficiency, and U is the utilization of the system. Capacity output relationship. The system capacity is less than design capacity because of long range uncontrollable factors. The actual output is still reduced because of short term effects such as breakdown of equipments, inefficiency of labor. The system efficiency is expressed as the ratio of actual measured output to system capacity. That means we can say that system capacity is actual output system capacity. There are another capacities, terminology which are associated with it, or that means they are included into it, is licensed capacity. Capacity licensed by the various regulatory agencies or government authorities. This is the limitation of output exercised by the government. Installed capacity. The capacity provided at the time of installation of the plant is called installed capacity. What is rated capacity? This capacity is based on the highest production rate established by actual trials is referred to as rated capacity. Now, how to perform a manufacturing capacity analysis? A capacity analysis can be an excellent solution for auditing a manufacturing plant and diagnosing if there is hidden capacity waiting to be unlocked. What is manufacturing capacity? The goal of every manufacturer is to run its operations at full capacity. But what is meant by manufacturing capacity then? In short, manufacturing capacity represents the state in which all equipment and resources within a company are utilized at the highest operation rate for the product mix and volume their industry requires. This means that all processes from operations to maintenance are optimized with a set of amount of resources and no unnecessary downtime is incurred. When this condition is reached, the equipment has reached full capacity. Now, how to perform a manufacturing capacity analysis? Companies that perform a manufacturing capacity analysis are able to reduce downtime and wastage. They can also mine the data to optimize processes and streamline workflows. Doing so can help them understand what the existing constraints are and make real time decisions to solve the problems as they happen. For companies looking to improve their manufacturing capacity, there are steps required to unlock existing capacity. Step one is benchmark data. Benchmarking includes determining existing capacity, machine speed, quality losses, downtime by categories such as breakdown, changeovers, and performance losses must all be measured to determine the current capacity. Second step is to analyze downtime. Once a manufacturing operation has benchmarked its data and understands its true utilization, a downtime analysis must be conducted. This involves managers, technicians, manufacturing engineers, operators, and other who can help to identify all the reasons for downtime and plan how to reduce or eliminate it. The third one is rollout process changes. Managers are now equipped with accurate and verifiable data that derives real changes at this point in the capacity analysis. These changes can be used to tackle the most significant capacity constraints, unlock the hidden capacity to eliminate overtime, reduce the need for capital expenditure. Step 4 is unlocking hidden capacity. A capacity analysis coupled with advanced data capture and analytics can help companies find their path to full capacity quicker than the most would think and lead to a leveled production. Step 5, optimize your production with accurate capacity planning. The overall goal of many manufacturing companies is to create an optimized and efficient schedule to have balanced flow between supply and demand while minimizing the wastage in terms of cost. Capacity limitation. Since we are working on capacity, we are talking about the capacity. Everything has its limitation. Now comes the capacity limitations. It is important to understand your capacity limitations so that you can identify areas of improvement and develop a capacity plan that is just right for your organization. How to perform a manufacturing capacity analysis in your business. Most manufacturers have experienced time where the demand for products or services surpassed the actual available capacity to fulfill those demands. These obstructing situations highlight the requirement for proper analysis of the capacity you have and its usage to recognize the roots of the issue. Manufacturing capacity analysis is a process of recognizing the available capacity for your industry, which contains the available inventory holding cost, machine capacity, as well as the labor capacity, and many more. Efficient use of manufacturing space, labor, and optimized equipment performance are vital parameters for companies to derive systematic production and achieve the highest profitability. Now we move to Unit 5, that is design of manufacturing goods and services. First of all, we will see what are manufacturing product design and process basics. We'll start with quality of products. Because of the tangible nature, quality of products can be standardized and measured. Customers tends to measure the performance of product against the following dimensions. The first one is confirmation to specification, either implied in the advertisements or specified in writing. Manufacturers promise certain standards of their products. When the customer buys or use the product, they expect the product to contain the advertised specifications. Second one is value. Customer expect value in return of the money spent. Higher the money spent for a product, higher is the expectation of the customer. That is the difference between using an Apple phone and using MI phone. Fitness of use. A product is purchased for a specific set of purposes. The customer would always ask whether the product is actually fit for the purpose for which it was purchased. Fitness of use does not include its mechanical and chemical properties, but it also includes its appearance, style, durability, reliability, craftsmanship, and serviceability. But these are the factors which normally creates the quality of the product. After sales service, many products are used repeatedly over a period of time. In this process, it may need maintenance. Does the seller have the ability to service the machine? Fifth one is psychological impression. People often judge a product by its ability to project a special image of them. How the product enhances its image is very important to the customer. Production design. Next part is here the production design is the structuring of component parts or activities so that as a unit they can move a specified value. It usually begins with the development of set of detailed specifications. New product and service ideas come from various sources, including customers, top management, and staff from marketing research and development, production, and engineering. Product selection, definition, and design takes on a accounting basis because so many new product opportunity exists. Mainly five factors influencing market opportunities are there, and they are economic change, sociological and demographic change, technological change, political change, and other changes. So, what are the phases of a product design? To design is to formulate a plan for the satisfaction of human need. The phases of design are described. Now you see that initially at the top, it is the recognition of the need, why it is needed, definition of the problem, synthesis, that means we're working on it, analysis and optimization. Then comes your evaluation. And at the last, after you have been performed, all that steps have been performed, it comes for the presentation. Now, once it is presented, the outputs are selected, we define, we design how other modifications, if required, can be done. That means it is an iterative process. Recognition of need. Recognition of need and phrasing the need often constitute a highly creative act because the need may only an age of discontents, a feeling of uneasiness, or a sensing that sometimes it's not right. For example, the need to do something about a food packaging machine may be indicated by noise label, by the variation in package weight, and by slight but persistible variations in the quantity of packaging or pack. Second one is definition of the problem. It must include all specifications of the product that is to be designed. Specifications are the inputs and the output quantities, the characteristics and dimensions, and all the limitations on these quantities. Third one is synthesis. After the problem is defined and a set of written and amplified specifications have been obtained, the next step is to design is the synthesis of the optimal solution. Fourth one is analysis and optimization. Synthesis cannot take place without both analysis and optimization because the product under design must be analyzed to determine whether the performance complies with the specification. Fifth one is evaluation. It is a significant phase of the total design process. Evaluation is the final proof of a successful design. Then comes your presentation. The designer has also to sell the new idea. The designer should must be afraid of possibilities of not succeeding in a presentation. Then comes your product analysis and testing. Product analysis and testing is the determination of how well the product's actual quality, performance, and costs conform to the design objectives. Detailed design concerns the product's functional, form, and production design. Functionally, the product must have the characteristics to perform the desired functions in a reliable manner. The process relates to the physical packing of the products, which tends to be more critical for consumer goods than for an industrial goods. Production design is concerned with how the product is produced. Alternative machines and sequences are typically available. Designer must plan the assembly or production sequence in a manner such that the specified quality is delivered within acceptable costs. The product development process. Developing a new product is a major undertaking that has various identifiable stages. As development progresses, through each phase, its risk and potential are scrutinized, both technically and business wise. Product development helps a product or service attain success. This includes marketability, manufacturability, and serviceability. Product developments give a number of benefits. Now the thing is that what are the stages of product development process? This product development process undergoes number of stages such as need of identification, then comes your advanced product planning, advanced design, detailed engineering design, production process design and development, product evaluation and improvement. Then the last which comes product use and support. What is the need of identification? Once a product idea surfaces, it must be demonstrated that the product fulfills that consumer need. Next come your advanced product planning, that is the feasibility study. The major hurdle for a product is its feasibility study. The purpose here is to anticipate whether the product can be successful or not. This comprehensive review involves a technical assessment of the ability to produce. Secondly, a primarily assessment of the market. And the third one is an evaluation of the economics of the proposed product and processes. Third one is advanced design. Fourth one is detailed engineering design. In this stage, it is a series of detailed engineering activities to develop a product, the components, the materials, sizes, shapes, and so on, which are a part of the system. This process typically involves analysis, experimentation, and data collection. The fifth one is production process design and development. Working with detailed product design, engineers and manufacturing specialists prepare plans for materials acquisition, production, warehousing, transportation, and distribution. This stage involves planning too for production and control system, computer information system, and human resource system. You can see that all the departments of the organization are involved in this step. Product evaluation and improvement. In this stage, field performance and failure data, technical breakthroughs in materials and equipments, and formal research all are used to monitor, analyze, and redesign the product. Product use and support. An important stage of product development considers support of the consumer who uses the product. Then comes your process flow design and process selection. A process is the approach that an organization takes to transform resources into goods and services. The objective of process strategy is to find a way to produce goods that meet customers' requirements and product specifications within the cost and the other managerial constraints. There are mainly three types of processes. These are process focus. Here, low volume and high variety processes are process focused. It is also known as intermediate process. The facilities are organized around processes. The layout and supervision have a process focus. Then comes your product focus. Here, high volume, low variety processes are produced and they are focused. The facilities are organized around the products. They are also called continuous processes. They have very long continuous production runs, such as paper, tin, oil, etc. The third one is repetitive focus. The repetitive focus line is the classic assembly line. Repetitive process use modules. Modules are part of components previously prepared, often in a continuous process. The repetitive process is widely used, including the assembly of virtually all automobile and household appliances. Now, see the comparison among process, repetitive, and product focuses. If we talk about process focus, here the quantity is small, large variety of products are produced. Operators must be more broadly skilled. They have many jobs instructions because each job changes, which has different specification. Raw material inventories are high relative to value of the product. Work in process is high as compared to the output. Finished goods are usually made to order and are not stored. Fixed costs tends to be low and variable costs are high. Costing, often done by the job, is estimated prior of doing the job, but known only after the job is completed. In second case, it is repetitive focus. Here, long runs, usually a standardized product with options, are produced from modules. Employees are modestly trained. Repetitive operations reduce timing, training, and changes in the job instructions. Just in time procurement techniques are used, what we call it as JIT. Here, since JIT has been implemented, it is also used in inventory techniques also. Finished goods are made to frequent forecasts. Fixed costs are dependent on flexibility of the facility, and the costs are usually known because of extensive prior experience. If we talk about product focus, here large quantity and small variety of products are produced. Operators are less broadly skilled. Work orders and job instructions are few because they are standardized. Raw material inventories are relatively low to the value of the products. Inventory of work in process is low as compared to the output. Finished goods are usually made to a forecast and product flows. Fixed cost tends to be high and variable costs are low. Because fixed costs are high, the costs are highly dependent on utilization of the capacity. Then comes your product life cycle stages. Operations manager needs to be aware of the timing and stages that derive the development schedule of new product. It can be a goods or services, and the production and delivery schedules of the company mature products. The product life cycles are composed of four stages. All product and services go through the following stages. First one is introduction to the market. Then comes your growth of volume and share. Third one is maturation, where maturity is the phase of relative equilibrium. And the fourth one is the decline at risk because of the deterioration in sales. Introduction and growth of new products, that is, can be in the form of goods or services. There are two new products, early phases of life cycle stages. These are initial introduction and sales growth of the product. The idea for the product and its development precedes the introduction. The entire team works on ascertaining the marketing feasibility of the idea as well as the feasibility of making it and delivering it. Research and development, what we call it R&D, may have made sample products so that the market research can test its customer acceptability. When it is approved, production or operation management and engineering swing into action to create the production system that can make and to assemble it. But because here we have to decide either to make that part or to assemble it. During this process of bringing the idea to reality, there are many make or buy analysis. None of this is easy. It takes a lot of effort and attention to detail. There is much time and talent needed to conceptualize the product, design it, specifies, organize the process for making it, cost it out, pilot test run, and so forth. When the product is accepted, it is released for production and marketing. All of these takes the place in introductory stage. Maturation and decline of new product. When the new product or services stop growing, it is considered mature. This means that its volume is stabilized at the saturation level for that brand. The competitors have divided the market, and only extraordinary events such as strike at a competitor's plant are able to shift share and volumes. During the introductory phase, P or OM had to deal with producing larger and larger quantities of product. Now, the marketing production relationships reaches equilibrium. Marketing takes specific action during this phase to maintain the product's share of the market. Prices often are lowered. Coordination between P and OM and sales is essential to meet delivery scheduling times. Finally, the design to lose product begins to lose share, volume drops, and depending on the strategy, the product is either staged or terminated. It is expected that a new product will have been introduced previously that has grown to a reasonable extent. The cycle of the new product is similar to that of one that is replaced it, that it goes through introduction, growth, maturing, and decline. We can see that here it is an inverted tub type diagram where initially at the bottom we have introduction. As production starts and the sales volume increases, that means the share in the market is developed. It goes up to an extent, then it becomes flat parallel to the x-axis, that is with the time. There is no change, time is increasing, but there is no increase as such in the market share. That phase may be termed as the maturity stage. And after a particular time, it starts coming down. And at a particular level, when the organized company decides that further sales cannot be increased or the amount profits cannot be generated, so they decide to terminate the distribution. And once launching of the new product, again this cycle repeats. Demand prediction in life cycle stages. Life cycle stages provide a classification for understanding the kinds of trends that can be extended in demand. During the introduction, the demand is led by desire to fill the pipeline. This means getting the product into the stores, warehouses, or wherever it must be to supply their customers. When growth starts to occur, there is a trend line for increasing sales. Now, design for manufacturing. What are the guidelines? Design for manufacturing, that is what we call it as, or what we will be using the term DFM, and design for assembly, that is DFA, are the integration of product design and process planning into one common activity. The goal is to design a product that is easily and economically manufactured. The importance of designing for manufacturing is underlined by the fact that about 70% of the manufacturing costs of a product are determined by design decisions, with production decision is responsible only for 20%. The heart of any design or manufacturing system is a group of design principles or guidelines that are structured to help the designer reduce the cost and difficulty of manufacturing an item. The following is the list of these rules. Reduce the total number of parts. Develop a modular design. Use of standard components. Design parts to be multifunctional. Design parts for multi-use. Design for ease of fabrication. Minimize assembly directions. Maximize compliance and minimize handling. Now, these are the criteria which have to be kept in mind. Competitive advantage. The firm innovates and develop new products for unique opportunities for competitive advantage. Market share gain. New products introduced in the marketplace provided additional first moreover advantages to the company. By developing a new product, a company can quickly capture a big share of the market before competitive products are introduced. Higher profitability. During the early stages, a new product faces less competition than a product in a mature market. Therefore, its profitability tends to be higher. As the market becomes saturated with several competitive products, price starts falling and profit margin decreases. Enhancement of corporate image and brand name. The developments of innovative and creative new products is a very powerful source of goodwill and creates a positive corporate image. Brand equity measures used in marketing shows that firms with more successful new product development efforts command higher respect from customers and profitability. Faster competitive response. Having a systematic process for new product development in place can introduce new products quickly after a competitive product is launched. Sony PlayStation, Microsoft Xbox, and Nintendo's Wii compete fiercely in the video game industry. Operating cost and capacity utilization. The product development effort is often closely linked with process development. New product provides the opportunity for enhanced sales as the demand for older products decreases over the time. What are the different types of designs? First one is original design, that is innovation. Example is microprocessors. Adaptive adaptive design, that is novel application, that is inkjet printing concept for rapid prototyping. Redesign, without any change in the concept of original design. Variant design, changing some of the design parameters. This is basically used in automobile industry. Selection design, selecting the components with the needed performance, quality, and cost from catalogs of potential vendors. Next one is industrial design. It is an appeal of products to human senses. What are the different steps in design process? It is basically consists of 7 8 steps which are performed, which are required to be performed, and they are also some of them are interrelated. So we start with that is the design concept, design for assembly, selection of material and processes, and the early DFM cost elements. Best design concept, design for manufacturer, that is DFM, prototype, and then comes the production. But we can see that as far as the design concept is concerned, we get suggestion and more economic material and processes while we are doing selection for material and processes. Then that change has to be performed again at the design concept stage. As far as the assembly part is concerned, suggestion for simplification of product needs to be studied, and once that has been performed, again that is reported to the design concept. What are the advantages of applying DFMA during product design? Today, products are tending to become more complex, made required in increasingly large numbers, intended to satisfy a wide variation in user population, required to compete aggressively with similar products available in the market, required to consistently high quality. Through DFMA, it is possible to produce competitively priced, high performance products at a minimum cost. The advantages of DFMA during product design are: DFMA not only reduces the manufacturing cost of the product, but it helps to reduce the time to market and quality of the product. It also provides a systematic procedure for analyzing a proposed design from the point of view of assembly and manufacturing. Any reduction in the number of parts reduces the cost as well as the inventory. And DFMA tool encouraged the dialogue between the designer and the manufacturing engineer during the early stages of the design. What is the definition of DFM? Process of proactively designing products to optimize the manufacturing functions, assures the best cost, quality, reliability, safety, time to market, and customer satisfaction. This definition was proposed by D. Anderson. Design for manufacturing or design for manufacturability, it is the optimization of a part, product, or components design to create it cheaper and more easily. The importance of DFM is that it affects manufacturing cost and productivity. Designers play important role not only in shaping but also in manufacturability cost life cycle of products. There are five principles that are examined during TFM. They are process, design, material, environment, and compliance and testing. Ideally, DFM must occur early in the design process, well before tooling begins. In addition, properly executed DFM needs to include all the stakeholders, that is, engineers, designers, contract manufacturers, mold builders, and material suppliers, all those who are involved in the product. This cross functional DFM intends to challenge the design, to look at the design at all levels component, some subsystem type, and holistic levels to ensure that design is optimized and does not have any unnecessary cost embedded in it. What is the design for manufacturing and assembly? The concept of DFM is not new. It dates back way back early in 70s when Lee Blanc, a Frenchman, devised the concept of interchangeable parts in the manufacturing of muskets, which previously were individually handmade. DFM is the practice of designing products, keeping manufacturing in mind. Design for manufacturer means that design for ease of manufacture, for the collection of parts that will perform the product after assembly. Similarly, DFA is called the design for assembly. DFA is the practice of designing products with assembly in mind. Design for assembly means the design of the product for ease of assembly. So, the design for manufacture and assembly is the combination of DFM and DFA. DFMA is used for three main activities as the basis for concurrent engineering studies to provide guidance to the design team in simplifying the product structure, to reduce manufacturing and assembly costs, and to quantify the improvement. Secondly, as a benchmarking tool to study competitors' product and quantify manufacturing and assembly difficulties. And thirdly, as a should cost tool to help control costs and to help negotiate suppliers contracts. What are the factors which affect DFM? The goal of DFM is to reduce manufacturing cost without reducing performance. In addition to the principle of DFM, here are five factors that can affect design for manufacturing and design for assembly. First one is minimize part count. That means reduce the number of parts. Standardized parts and material. Design for efficient joining. Fourth one is minimize reorientation of the parts during assembly and machining. And the fifth one is streamline number of manufacturing operation processes. Now, we move to Unit 6, which is related to computerized layout design algorithms. Since we talk about computerized layout design, that means we will be talking about computers. Here, automation also takes place because there are different factors and different tools which are used. So first of all, we start with automation. Automation means the use of automatic equipment and machines to do work previously done by men. Automation issues are more related and important to the manufacturing process. Think of a cutting machine in a garment factory. This machine cuts a huge amount of cloth at a time. In all sectors, machine may work easy and short. Technology is a powerful tool for developing competitive advantage via both product and process strategy. The firms that achieve the most success at using technology as a competitive advantage are organizations that plan for a more distant time horizon, have a narrow product line, that is, they stick to their knitting and know their product and customer exceedingly well, have strong internal technical capabilities that are tied to their strategic analysis, have consistent and stable strategic management. That is, they seems to be a better at the implementing the changes necessary for the effective use of technology. Now the question is that what is the degree of technological change, mechanization, and automation is strategically better for any organization? Responding correctly to this question is often critical to the survival of the business. It takes experience and wisdom to take to make such a decision. Some of the mechanization alternatives that business face today are flexible manufacturing system, what we call it as FMS, computer aided design CAD, and that is CAI. We will start with flexible manufacturing system, that is FMS. And FMS is a process technology that can produce a moderate variety of products in modest volume and can do so quickly and with high quality. Operating costs and tools can be reduced within FMS, but an FMS requires very large capital investment in equipment, planning and control systems, and human resources. A flexible manufacturing system is an arrangement of machines interconnected by transport system. Computer aided design CAD and computer aided manufacturing CAM, what we call it as CAD and CAM. It is a use of computer to develop the geometry of a design. Product design is generally enhanced through the use of computer aided design. Initially, that was done by hands, draftsmen, engineers. Now, it is being done by CAD operators. They no longer they are engineers, but they are using computers and the software. CAD techniques are now used in mechanical engineering and electrical engineering, where CAD is used. A design engineer starts by developing a rough sketch. The designer then utilizes a graphic display to construct the geometry of a design. When a geometric definition is completed, a sophisticated CAD system will allow the designer to determine various kinds of engineering data, such as the strength or heat transfer. CAD will also allow the designer to ensure that parts fit together so there will be no interferences when parts are subsequently assembled. Now, here is basically a simple example how making a bedside cabinet is developed with the help of CAD and CAM. Now we can see that at the top the raw material is there. For that raw material, with the help of computer software, we plan the cutting plane. Then that input, the input of this, what has been designed, is given to the beam saw machine. That material has been now converted to step number 4. Here, at this step, at the edging machine, edging process has to be performed, which is again done by at step number 2. After that, drilling has and routing programs are provided by the help of the software. These boards at step number 4 goes to step number 7, where this input is in the form of number of holes at the position, and that input is given to CNC machines. Now after that, machine components are ready for the assembly at step number 8. After that, it is they are joined together, and a cabinet, bedside cabinet boxes. Now we see that the question arises, this would have been done by human being also, but now to increase the output, we use softwares. With this, we will be concluding today's session.